Unit 4. We're now on 4.3, probability. And we are doing part 1, where we're going to learn some new words, terminology. Now, I would suggest you really make sure you understand these first parts, the parts that still look simple, because it gets harder, and it's usually because you didn't really get these first things that the rest gets harder. So please make sure you get the basics. The word tells you probability is that we think what will probably happen. And I see I wrote the word wrongly here, right? Probability, not probability. Probability. What it would probably happen is what we're saying. It fits in with your data because mathematicians don't like the vagueness of the probability. So we like to put a number to it. And in order to put a number to it, we use statistics. So we use stuff that's already happened to decide what we think might probably happen in future. So here's some words we need to know. An experiment is a process, an action, a process with uncertain outcomes. Okay, so as an idea, if I go around and I smile at everybody and I want to see if they automatically smile back at me, then I'm doing an experiment. But I don't know if they will smile back at me, so it's uncertain. They could think I'm crazy, or they could think I'm trying to be funny and just get angry with me. So I would go and I would write down the results for each person, or for each time I did the experiment. An outcome is one of those results, a single result of an experiment. So the first person I go to, I see if they smile, I take a note of their reaction. That is an outcome. The sample space is the set of all possible outcomes. So as in, when I smile at the people, one possible outcome is they smile back. Another one is they ignore me. Another one is they frown at me, etc. We call the sample space capital S, and then NS, sorry, this is not over, NS is number of possible outcomes. How many? So S is the set, so S you would write what could happen. NS would mean how many did I get. An event is a subset of a sample space. And usually an event is something that I choose. So I could choose to say, I want to see how many smile back at me. So the fact that they smile back is an event. Or I could make more than one thing an event. So I can say, event 1 is people smile or they look happy even though they don't smile. So that consists of 2 outcomes. And the event is called E, and similar we can say NE is the number of elements. And then last thing, probability. Let's see if I get it right this time. Probability of an event. I'm just going to say we would write it like that. So read this. The probability of event E happening. What are the chances that event E will happen? And that is taking not, so notice the difference between the P and the N. The probability of event E happening is how many times did I get that reaction over all the possible outcomes. Right, let us do a nice example here where we show how to write them. This is going to be my experiment. This is going to be my sample space. Then I'm going to choose some or other event. Then I'm going to see how many possible outcomes there are in this event, and I'm going to see how many possible outcomes in the sample space. So flip a coin. If I flip a coin, what are the possible outcomes? It could land on head or it could land on tail. Right? So that is my sample space. Event is the one that I choose. So I'm going to choose event E to be get a head. How many of these on the sample space are heads? 1. How many elements in the sample space? 2. Let's add one more thing. Probability of event E is then 1 over 2. Now think about it. It's pretty logic. If I flip a coin, chances of getting a head is 1 out of 2. We just say it without thinking. What if I flip 2 coins? Now, I have to think of it in order. Even though we don't flip them both at once, you're going to flip one and then you're going to flip another one. So my sample space is they could both have been heads, head. Or the first time I could have had head and the second time I could have get a tail. Or I could first have gotten a tail and then a head. Or I could have had 2 tails. So notice head then tail is seen as different from tail then head. Right, what am I going to make my event? Get at least 1 head. Right, so what does this consist of? I'm actually going to write them out here. I could have had head, that's at least 1. I could have had head, tail. I could have had tail, head. So that is 3 there, whereas S has 4. So the probability of that event is 3 out of 4. Let's toss a die. Now, I know we generally say a dice, but dice is actually the plural, so a die is the singular. What could I get? I could get 1, 2, 3, 4, 5, or a 6. I'm going to say my event is get an even number. So that would be 2 or 4 or a 6. So there are 3 values in my event. There are 6 values in my sample space. So this is 3 over 6, which simplifies to a half. Well, think about it again. The even numbers are exactly half as many as all the numbers. Let us do another toss a die. So I'm not going to fill in S again. It's the same. I'm going to make a new event. Just make a line here. Get a number that is higher than a 4. So what are the possibilities? I can have a 5 or I can have a 6. How many are there? 2, still 6. So 2 out of 6, which is 1/3. Right, let's do 2 more with toss a die. I just want to show you some more things here. So stick with toss a die again. And still the same here. I'm just not rewriting it. This one I'm going to say get a 10. Well, there are no 10s on a die. This is still 6. 0 out of 6 is 0. Right? So, what am I saying? If I toss a die, the chances of it landing on a 10, and it's a 6-sided die, is absolutely 0. Last one. Can we fit it in? No, I won't have space for that. We'll do that in the next one.